Okay, so I think this recording is running. Yep, it is. All right. So previously I made a video about using variables in simulation. And like I said in that video, I'm going to try to start making more videos for you guys to explain things, just so that you can reference it later. I don't have to reach out to me every time you need some help. So yeah, and so I can teach you more tips and tricks and share the information more easily. So in the last video, I talked about using variables in your simulation. We set this all up. In this video, I want to talk about using the calculator functions a little bit. And I think you're going to need this in the next lab. And using calculator functions is very useful when you want to get some sort of information from your simulation, but you don't want to take the time to manually extract it from your uh, plots every time. So an example is looking at this ESD protection circuit again. One thing that you guys were looking at was how high of a volt, or what's the highest voltage that this V out node hits. We need to make sure that's um, under 5 volts. And so how I think you guys did that and how we kind of told you to do it then was to run your simulation. So here I'm using an initial condition of 2000 volts. And if I expand this, I can see my output node here. I get up to about 4.057 volts. And I can add a marker if I want by hitting M and mark that. And so this is how I showed you guys how to do this. But if you do this, then, if you create a bunch of different plots using the variable sweep, then you have to look at each one. And it's kind of a pain to do this, especially someday if you continue on in industry, you have to create big sweeps, lots of parameters. And it's a real pain to have to do this. So a better way is that we can use functions to calculate the maximum. And how you do this is there's a couple ways. I'm going to show you both of them. So the first way is you go to the calculator. So you hit this tools, go to calculator, and that opens up this. And this should be blank when you start. And yeah, this calculator has this window here where you can create calculations. It has a stack, which I think stores your old calculations. It has a functions panel down here, which in this drop down, you can go to all if you want, and that'll show all the different functions you can use for doing your calculations. And I think if you click on one, okay, no, it doesn't really give you information about it. So uh, yeah, and then up here at the top, you have these different weird things. These are for getting information from your schematic. And so V stands for voltage, I stands for current. VT is a transient voltage waveform. So if you're running a transient simulation and you want to plot a voltage or get a voltage waveform from it, then you'd use VT. So you can see actually when I was doing this, I was using this VT of like V in, VT of V out, and that's basically just grabbing the voltage waveform for each of these nodes, and then I can plot it. So the T is for transient, F is for if you run a frequency sweep simulation, which we haven't done in this class, and I'm not sure if we will. DC is for just a DC simulation with no sweeping. S is for when you run a DC sweep. So if I were to set up a DC simulation, I can choose to like sweep a component parameter or a design variable, which I think we've had you guys do in this class. So if you did that and you wanted to see the like output voltage as you swept a parameter, then you'd use that VS or IS. And O is for an operating point. I don't know if we'll talk about that in this class or not. I think we will in the next lab. Yeah, and then there's different things. I'm not sure what all these do. I'm not sure what the N, I think it's for noise simulation, which we won't do in this class. And then all these different ones over here are for doing like S parameter simulations, which is for high frequency design, which we don't touch on in this class. So anyways, so if I wanted to calculate the maximum voltage that my output reaches, instead of having to plot it like I showed earlier, the first thing I do is I click on VT, That's going to open up my schematic, and then I'm going to select the node that I want to grab the voltage waveform from. So for this simulation, or for my purposes here, that's V out. So if I click on V out, then it'll create this VT like V out. And then if I want to calculate the maximum value this reaches, I can use a function called ymax. And I can search for the function using this little search bar. So I'm going to look for ymax, and I see it right here. I'm going to click on it, and then it adds this ymax to the calculation. And if I want, I can, I think it's this button. Okay, I can hit this evaluate, and it calculates the value. So it's giving me 4.062 volts. And that's from my last simulation. What's more useful is if I go over to this little gear with an arrow and click on it, and then close my calculator. If I go back to my Maestro outputs, it adds this calculation to my outputs. So now it'll automatically calculate every time I run a simulation. And I'll give it a name called max out. And now if I run my simulation, and wait, it'll calculate, and it'll actually put it up on my plot here, or I can go back to here and it'll show the value. And so that's really nice for doing that. Another way you can set up the calculation is, instead of going through the calculator, you can go over to this little probe with a plus, click the drop down next to it, and select expression. And you'll see that creates a new line in our outputs that has the same format as this guy. And if I double click in this box here and click on this little paper with a pen, it has this nice little box for, like, it's basically like the calculator, but it's a little smaller. And I don't have to go through all the other stuff. So if I want to look for a function, I can click in this guy, and I can look through the functions to find what I want. So let's say, right now I wanted to do, let's look for y max. Do y max, and let's search for v. That's not what I want. Okay, so I can find y max, or I can just start typing y max, and it'll show options. And I can just hit tab to autofill this. And then now I can look for, it actually has VT right here, but I can go through and look for the type of waveform I want, or start typing it. So if I start typing VT, it'll keep showing it. And I'll just hit tab on this guy. And then it'll show different things I can plot from, and I can also search. So right now I already know I want V out, and V out's right here. So I'll just hit like tab. And then it'll say, okay, now the last thing you need is a parentheses, so you can hit tab, and that's it. And it'll also show you information about the function up at the top here to help you as you fill it out. And once I'm done, I can hit this little check mark, or I can hit evaluate if I want, I think. I don't know, I haven't messed with this before. Or I hit this little check mark, and it'll save it here. And then I'll name this max out 2, and you can see it evaluates to the same value. So each one does the same thing. I'll just, I guess, delete this guy for now. Okay, this is starting to get a little long, but yeah, another nice thing is that if I run multiple values, let's say I did like 250, 500, 1000, 2000, 4000, and 8000, and I hit run, then it'll run all my different simulations. And we wait. It's always the worst part, is waiting for simulations to run. Oh, and I hope this video doesn't get too long. I'm sorry if it does. I'm trying to keep these short, but I also want to give you guys a lot of information. So, all right, so now you can see it starts running, and for each one it calculates. So, and then plots all my stuff. I'm just going to close this for now. So now I can see the maximum voltage that my output reaches for 250 volts, initial condition, 500, 1000, 2000, etc. And it just plots it. And so I can see my My ESD protection works up to the 2000 initial condition, but it fails at 4000. And so yeah, that's an easier way to plot it. Another last cool thing I can do is if I have a specification that I want this value, so in this case it's under 5 volts is passing and over 5 volts is failing, you can actually add a spec. So a spec is like minimize, maximize, less than, greater than, range. So I think range is like you can give it an upper bound and a lower bound, and if it's equal to either one of those values or in between those values, then it's in spec. Or you can do greater than, less than. Yeah, for now I'm just gonna do less than, and I'm gonna say 5. Because if this is less than 5 volts, then it passes. If it's greater than 5 volts, it fails. Then I'll go to my results. And I'm gonna use another little trick is there's this little recalculate button that you can use. So if you click on this, it'll recalculate all the values. And you can see now it highlights the calculated values where I have the spec. So under 5 volts is passing. If it's, I think, like close to the value, then it'll say near, but it's still kind of a fail. And so this yellow is near, and if it's red, then it failed. And so that way you can quickly see where you're passing and where you're failing. It's just a good data visualization, especially if you ever have to run simulations with like 5 to 10 different specs that you're calculating. So yeah, that's all I've got. Hopefully this is helpful, and have a good day.